तेरा बेरोजगार गोरिए जिंदगी रही तो तैनू सोने च जड़ा दूं अजे यार तेरा बेरोजगार गोरिए जिंदगी रही तो पूरी दुनिया घुमा दूं अजे यार तेरा बेरोजगार गोरिए नी एक दिन तैनू आईफोन भी लिया दूं अजे नोकिया ना कर ले गुजारे
Hello.
Hello, yes, sir.
Hi, Aisha.
Yes, sir.
Just wait for a bit. Hello, Aishan. Am I audible?
Yes, sir.
Okay, भाई एक बार इंट्रोड्यूस कर दे अपने आप को if you want to.
Oh, sir. अभी आने
हाँ
के बाद.
हाँ sorry my mistake. Was quite excited.
Okay.
Yeah, so is it? Hi, Shorya. Hello. Hello, Shorya. Am I audible to you? Okay, sure.
Hey, hi, sorry. Am I audible?
Yeah, you are audible. So,
Yeah.
hi
Shall we
Aishan.
start?
Yeah, we are starting. So, Anshuman, you may begin with your introduction first for 1 minute, I guess.
Should we have our cameras on or something?
If you guys want to, it will be great. Aishman.
Okay, sir. So, shall I begin?
Yeah, sure.
Sir, my name is Ayushman Singh. I am from Triple IT Ranchi. I am in third year, fifth semester, and I have very interest in machine learning and artificial intelligence.
Yeah. Shall we start with the project then?
Yeah, sure. From now, Shorya, you may take this bit. I'm just a host sitting in the corner,
Okay.
nothing else. Yeah.
Sure. Okay, yeah. Sure, Anshuman, you can go ahead and show your project, I think.
Uh, Wait a minute, sir. Shall I share my screen?
Yeah, sure.
Is my screen visible?
Yeah, it is visible.
Yes, sir. So in this review, I gave two projects for your review. So this is the first one. This was the image captioning.
Okay.
In this, I have used VIT and GPT-2 architectures, which are present on the transformer and PyTorch as well.
Hmm.
So I mean, I
I
was
think
just
it should
beginning with.
be, yeah, I think it should be VIT encoder and GPT decoder. VIT is a encoder, right?
Mm, yes, sir. There's this. This has a typo. I just
Yeah. Okay.
skipped my. So I was just starting with the transformer, so I had read a lot of theory. I just wanted something to build to implement this and this seemed like a very good project, so which can include both the computer vision aspects and NLP tasks. So I went with this. Before directly landing at this, I was trying to use the VIT part with a different model. Like I used what do you call it, ResNets, DenseNet, and many other things. But the outputs weren't very great. It was just very vague answers basically. So
Okay.
I then I used VIT. So basically, the model includes 12 VIT stacks and 12 GPT stacks, which is and standard transformer models.
Okay. Are these already pre-trained or you are randomly
No, no.
initializing the weights?
So these were partially pre-trained, like the GPT, the VIT was fully trained, and GPT was also pre-trained. But then I basically ran 10 epochs. So for the first two
Okay.
epochs, the VIT was not training;
Frozen.
it was
Frozen. Okay.
frozen.
Okay. Hmm.
So, but after the two epochs, I let all the layers train.
Okay. Okay. Got it.
So the training set used was the Flickr 30K, which has five captions for each images and 30,000 images. So I personally don't have any resources to train the model on my own. So I was using Kaggle for this purpose. So basically, I just ran 8 epochs because it took 10 hours, and I wasn't quite patient enough to wait many days like for complete training. So these were the results. The loss.
So I'm assuming
Very,
that you are fully fine-tuning both the architectures, right? You are not
yes,
using
yes,
any
yes.
kind of. Okay. Got
No,
it.
no, no. These are not fully pre-trained model, but partially pre-trained, and then I was fine-tuning it.
Okay. Okay. So I mean to say, like for fine-tuning purpose, right?
Yes, sir.
You are using it like you are fully fine-tuning. All the gradients are flowing through the
Yes,
model
sir. Yes, sir.
itself, right? You are not
Yes,
using
sir.
any kind of LoRa or anything. You are not using here,
No, no,
right?
no, 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 sir.
Okay. Okay.
This was, yeah. And so, I mean, if we see the predictions here, this was non-deterministic. Basically, I kept some temperature. So you see, the model predicts quite good here. Like it actually tells the bikers ride down a country road on a dirt path. It was very well, and these are others.
What is the metric that you're using over here to have like judge your model? Like for example, there are two sentences over here, right?
Yes,
So
sir.
they should be a metric to like you. I mean, you're training for 8 epochs.
Yes, sir.
I am assuming that you would be using cross entropy loss, correct?
Yes, sir.
And but what is the metric that you are using for judging your model? Like whether it
Judging.
is,
Yes,
yeah.
sir. Sir. So actually, first I just trained the model and got these outputs. So, but after some time, I was looking into it that what metrics should I report. So after some time, after 10 or 15 days, I was idle. So I used the losses like what do you call it? Wait a minute. I haven't updated it here. Like blue scores, yeah, I was using blue scores and other metrics. I'm just unable to recall them right now. But so if you give me a moment, I can pull up the metrics.
Yeah, sure. So actually, yeah, Blue Score, Rugel, these are lexical metrics. These are actually a
Yes,
good to start metrics for text generation tasks. You
yes,
can also go ahead and see some metrics which are not actually lexical, like totally lexical, because what happens is, if there is a sentence and there is a negation in between, right? Then also, like for
yes.
example, this is a cat and this is not a cat. In both,
Mm-hmm.
if you see the blue score and Rugel score for this, right, you might get a very high score because most of the words are matching in this case.
Mm-hmm. Yes,
Even
yes,
if the order of the words are not like so, like this might be an issue. You can look ahead for certain metrics which are actually. So there is a score called BERT score,
yes, sir,
BERT,
sir.
BERT score. So
Yes, sir.
you can use those scores for like finalizing the model at which epoch you should stop and what is the best validation metric that you're getting and then finalizing the model actually, yeah.
Yes, sir. So I have the scores here. So I scored everything on the Flickr 8K dataset. So I was thinking, let's just give it a new test set. which it has never actually seen. So the blue one score was 0.57 and the blue 4 was 0.21.
Okay.
And I also calculated cider score and meteor score. So
Okay.
cider was 0.4 and meteor was 0.25.
Okay. Seems fine only. Yeah.
Yes, sir.
Um. Yeah.
I was
So.
comparing it with the SOTA techniques today. So I came to the conclusion that these were the scores which were like SOTA in 2016 to 18.
Correct.
But
So right
yes,
now the architecture that you're using, right? Can you go back to the architecture?
yes,
So one problem that happens in these kinds of architecture is like, so first of all, you are freezing the VIT encoder, right, for two epochs.
yes, sir.
So the gradient is only flowing through the GPT decoder, right? So
Yes, sir.
actually, what ideally should happen is like, there should be an alignment in between the two models, because the embeddings that the encoder is generating and the embeddings that the decoder is expecting, these are two different embedding spaces initially, right?
Yes, sir.
So you want them to be projected into the same space such that the cross attention that you are calculating finally
Mhm,
should be
mhm.
able to, like, finally the logics that comes, right, that should make sense, correct?
Yes, sir.
So ideally, what should happen? Like, these architectures were actually used previously, and these are really good architects. Like, this is a good architecture to start the transformers. Cross attention and everything is here. But okay, so a simpler architecture right now that most of the people use for captioning and text generation or multimodal aspects, right, is like. I think you are aware about Lava
Yes, sir. Yes, sir.
architecture, is there?
Yes,
So
sir.
in that particular architecture, what we do is like, instead of having it side by side and calculating the cross attention, we just put it in a series manner. So the encoders embeddings just are just put into the like decoders, so LLM decoder model, and directly the text starts gets like the text is generated on top of it. So there are certain famous architectures, like there is Florence model is there, then there is Lava model is there, then there is uh, I think Phi 3 Vision is there. So these are few models that I'm just telling you about. These are multimodal architectures. You can give it a try as well. Right now we have Llama 3.2 1 billion also. That is also a one like text multimodal text generation
Mhm.
model only. So I think this is this project is actually good to start the transformers at like understanding what is cross attention, what is multi-head attention, everything.
Yes, sir.
So yeah, only the thing is like, I think you should add metrics, and the metrics should make sense.
Yes,
So
sir.
if you're trying to justify that your model actually predicts well and gives a good caption,
Yes,
metrics is something that the people would be looking at metrics only, right? They don't care about
yes,
what
yes.
was the loss, like 0.8 or
Mhm.
0.79 doesn't matter. It should be like what exactly the metrics are, and the metrics should also make sense, right? So
Yes,
you
yes.
should be, I think you should include that as well. Yeah.
Okay, sir. Sir, I had another project which I wanted to show actually,
Yeah.
and that was this music gen. So
Okay.
basically, I was very fascinated about how the models used to generate new pieces actually.
Mhm.
So I was looking into this. So this was a simple model. I used Grew here,
Okay.
and the model was actually quite simple. It was nothing very
Gated
new at all. Yes,
gated
sir.
recurrent unit, right? So
Yes,
but
sir. Yes.
what is the base here, like you're using
So there is no
recurrent.
base. I mean, yes, I mean the Grew layers which are already in the PyTorch, but the
I
architecture I
got it.
wrote it by myself. Yeah.
Okay, okay, got it. Yeah.
So there was actually a data set in on Kaggle. It was classic music MIDI. It basically has the MIDI files which are notes and chords with the timestamp. So I trained it on 48 music pieces. I mean the data set loading part was actually quite time consuming rather than the training. So
Okay.
uh, these were the training loss, but
Any
I,
specific reason we see a kink in between?
sir, actually, I was using the Lightning module. So I was new to Lightning module. I was actually trying to practice it. So these are basically the each and every step. These are not the epochs.
Yeah, yeah,
So
that I know. That I know. Mm.
yes, sir. So
No, I
I
mean
mean,
to say
king
like
in
there is.
validation loss.
Yeah, no, no. In training loss also, I'm seeing that it goes up at one
Yes,
point,
sir.
right? So any
Yes, sir.
specific reason for that?
But actually,
You
I
are using
wasn't able
any?
to
You're
quite
using
grasp
any?
this why it's happening.
You're using any learning rate schedulers or anything for this?
Yes, sir. I was actually scheduling this. It
Okay,
went 10th of a learning rate after some time.
I see. So it is like gradually decreasing, or it is increasing first as a warm-up step and then going down?
Sir, I started with 0.03 as initial learning rate, and after that, if I remember correctly, it halved after. Yeah,
Okay,
the LR went. I mean, the loss went stagnant, so it halved
okay,
every
okay.
5 or 10 steps.
This is like you give an initial piece of music and it generates on top of it, is it?
No, sir. Actually, it can generate like that, but in the predictions which I have shown here, these are completely from scratch.
Completely from scratch. Okay.
Yes, sir.
So, but there
No
should be
base piece.
an input, right? Like, or it is randomly generating it.
Completely random. Completely random. If you want to, then you can, but I didn't design my prediction. It's like that. I was just like start from any random sequence and then generate it like that.
Okay, but what is the metric here? Like,
So
how are you
actually,
validating?
yeah, I wasn't able to quite find any metric which could suit this, so I just had a survey. I basically circulated the forms on in my college group on social media, Reddit, LinkedIn, and I received many results from there. So basically, I asked people how much they, I mean, what do they think they are if they are a good musician or not, and how they rated the results. These five results basically here only.
I see. Okay.
So I weighted their results. Like if they think they are a better musician, I weighted them more. If they think they are just listeners, then I gave them less weightage. So if I
Okay.
remember correctly, they the 7.2 out of 10 was the public survey rating for
So
this.
it's actually able to produce random music properly, right?
Yes, sir.
Okay.
I mean, if you could listen, I don't know if this.
I
I don't think so. It is.
yeah. The audio is there. Yeah.
I know.
But what happens if we give it a start? Like we give it a, let's say, a 10-second
Yes.
music sample. Would it be able to generate on top of it?
Uh, so I don't think so. Uh, I haven't tested that, and it's purely for piano music only. So
Okay.
it wouldn't be able to like
No,
start from guitar music or
no, not
generate something sensible.
not from guitar, but let's say we give the piano music only, and
Hmm.
just a 5-second sample or a 10-second sample, and we ask the model, because this is like, so gated recurrent units, right? These are recurrent
Hmm.
neural networks,
Yes, sir.
so they are expecting a sequence only, and
Hmm.
taking the previous sequence they are generating on top of it, right?
Yes, sir.
So if we give a initial set of sequences, would it be able to
Yes, sir.
continue?
Yes,
Is
sir.
something I
Surely.
think you can test it out, I think.
Yes, yes, yes. Yes,
So
sir. I mean,
what
it
is
can do
happening in
this.
this model exactly? Can you tell me? The input is coming as a array of, I think, array
Yes, sir.
of
So there
amplitude,
are
right?
no, there are two things actually: the chord and the duration of the chord.
Okay.
Notes and chords and the duration. So
Okay.
these two embeddings you can see, one just embeds the chords and another the duration. Duration were I think there are 12 different durations,
Okay.
like quarter, a sixth, a 12th, a third, and so on. And simply then I do it like 200. Then I just concatenate the input and simply pass through a layer, the multiple grooves with some dropout. And
Okay.
yeah,
So
this is just a
how are
sequential
you?
input output.
So the two embeddings comes and
Yes,
you
sir.
just concatenate on the
Yes, sir.
0
The
and X.
embeddings. Yes,
I
sir.
see. Okay. And you're just passing it to the model
Passing
directly
to the
then.
model. Yes, sir.
Okay. Got it. Fine.
And
What kind
yeah,
of loss function you're using here?
loss function. I used MSE loss.
Mean squared error.
Yes, sir.
Okay. So a sequence will come, and then on top of it, your model will predict a next sequence
Yes, sir. The next
and
time and the chord.
time and the chord, and then you calculate the
MSE.
MSE between it. I see. But if the okay, Let me understand this. So if you have a fixed number of durations, right? You said that there are only 12 uh, 12 in
There
total,
are
right?
12 timings, yes, sir.
12 timings are there and number of chords are also fixed, I think.
I mean, yes, sir.
So
The
wouldn't it
the
make
quad
sense to, yeah, wouldn't
the
it make
chords are quite
sense?
large,
Quite large, I mean, like still, but how many
a
number of
finite amount. So the data set actually had, I think, 3,000 something. The
3000
combinations
chords?
of, uh, no, no, not
Combination of,
just chords. Yeah, the notes and chords, everything. If I
I
remember
see.
correctly, yes.
So I mean to say like your model has to predict the duration and which chord to
Yes, sir,
pinpoint,
yes,
right?
yes, sir.
So wouldn't it make sense to have a classification head at the end?
So
Uh,
this is the classification. You see, this is the combined sequential model which the outputs pass through, and then it predicts two here linear out one and linear out two different outputs.
okay, and then the
Yes,
final loss, but you're using is an MSE loss.
the loss will be calculated here only, the linear out one and linear out two.
So here you are calculating the cross entropy loss,
Yes, no, sir, the MSC loss was used.
MSE loss. But
Yes,
wouldn't it be better if we have a cross entropy loss here? Because this is a classification problem, right? Which duration
yes,
to
sir.
take out of the 12 and which chord to take. So kind of a combination, like you have two heads already.
Mhm.
So I think instead of having MSE loss, would it be better if we just pinpoint like, okay, I just want this chord and this particular note for like this particular chord for this many duration of time.
Yeah, yeah, sir. I can understand that. Yeah, actually,
I mean,
if I
I
yes, yes,
haven't
sir.
worked on this, but
I
yeah.
have used cross entropy. Yes, sir. I actually forgot what I
Okay.
actually used.
Okay.
I
And at
have
the
used cross
end, you are just adding it up.
summing the losses and then passing it through the model.
Okay. Okay. Got it. So you are getting the outputs and then you are passing it through a cross entropy loss, validation step, training step. I see. Okay. Um, Fine. Got it. So then you're having configure
So you are getting the
optimizers. Fine.
outputs
So
and
this
then
is
you
a lightning AI code. Got it.
Yes, lightning model.
I think it would be better if you can just try that out. I'm not sure whether it is possible or not. Like just give it a sample of music and
It is
try.
possible. So I was
I mean,
using
in
many
that
notebooks as
case,
a reference.
yeah, in that
So
case you would be able to judge your model also because if given a 5-second sample, the next 5-second sample it is predicting, right? It is actually
mhm.
matching with the original signal, like
Original, yes,
whatever
yes,
you
yes,
had, right? So you have
yes.
a ground truth in that case. Right now it is
Mhm.
just randomly creating it, right?
Yes, sir.
And it's like quite hard to judge whether your
Yeah.
model is actually generating properly or not because
Mhm.
sometimes it's like I'm not sure, I don't know much about music, but it's like if we hit some chord, whether what should be the next possible chords that should come, right? So if the
Yeah, yeah,
model
yeah.
is actually able to understand that or not.
Yes, sir. That makes sense, sir.
Mm.
So these were basically my two projects I submitted for review. So
Yeah,
what do you think about
projects are good actually. It's this project actually is something that I have seen for the first time. Piano music
it? Yeah,
generation.
yeah.
I've seen music generation, I've seen voice generation and everything from text and everything, but this is something new for me as well. So yeah, it's actually good. Both the projects are good. I think there are just minor things that you can try and make the projects better. Yeah,
Yes. Thank you, sir.
yeah. Mohit, anything else?
Yes, sir. Yes, sir.
Yeah, thank you.
Okay, sir. Thank you, sir.
Sure. Thank you. Bye.